So welcome back to another video, guys, in this computer organization course. So today we'll be focusing on converting from binary to decimal. So if you guys haven't seen the decimal to binary video, please go check that out. So let's just get started on converting from binary to decimal. So just as we said before, binary is either a zero or a 1. So that means there's only two digits. It's only a radix of 2. And the value of what power it is to really depends on where it's placed. So for example, if let's say we have 1001, the first origin point is going to go 2 to 0 all the way to 2 to 3. This one's 2 to 2, 2 to 2, and this one's 2 to the 1. So the way that we figure out from going from binary to decimal, we figure out the ones and we multiply it to their corresponding power of 2. So we're going to take this one and we're going to take this one. So it's going to be 1 times 2 to the 3 plus 1 times 2 to the 0. Easy, this is going to be 8 plus 1. And that is what it's in decimal value. So what meaning do they have? They have not really an inherent meaning. They can represent many different types of things. They can represent unsigned and signed integers, which we will learn in this chapter. They can do fractions, just like I'll show you in a second, characters, image, or sound. So in bit numbering, the leftmost is the most significant bit. As you can see, the leftmost is the most significant bit at a power of 7. So 2 to the 7, I believe we're looking at around 128 in decimal format. Let's check that to see. Is that correct? And then the rightmost bit is 2 to the 0, which is 1 in decimal format. So as you can see, going from the binary to decimal system, every binary number is the sum of its power of 2. So the way that we figure out, if we look at this over here, we have 1 here, so we're going to multiply that times 2 to the 7. We have in the fourth place, it's 1 times 2 to the 4. Same here with 2 to the third. Same here with 2 to the second. And the last one. So what we're really looking at is 1 times 2 to the 7 plus 1 times 2 to the 4th plus 1 times 2 to the 3rd plus 1 times 2 to the squared plus 1 times 2 to the 0. What we're looking at right here is 128 plus 16 plus 8 plus 4 and plus 1. So right here we're looking at 144 plus 12 plus 1 plus 1. And what is that? 157. So that's how we get this binary number right here into base 10. So how do we do 0.1011? Let's erase all of that. Start from right here. 0.1011. The way that works is when there's a decimal point, it goes the opposite way. It subtracts. So this first place is 2 to the negative 1. So 2 to the negative 1 is just pretty much 1 over 2, which is 0.5. So here you're just going to do the same exact thing. So here we have 2 to the negative 1, 2 to the negative 3, and 2 to the negative 4. So this one maps out to this maps out to this, and this maps out to that. So what we're going to do is 1 times 2 to the negative 1 plus 1 times 2 to the negative 3 plus 1 times 2 to the negative 4. I'm just including these ones so you can see. You can completely ignore them just like you see over here. 1 times, for example, 2 to the 7 is the same thing as 1 times 2 to the 7. But it's just a good way to see these bits. And you completely ignore the zeros. So what is 1 times 2 to the negative 1? That's 1/2. And 1 divide 8 is 0.125. And 1 divide 16 is 0.625. So 0.1011 and base 2 equals 0.5 plus 0.125 plus, I believe, 0.0625. 0.0625. And let me check. Plus 0.0625. And that answer will be 0.6875 in base 10. There you go. 0.685 in base 10. So what we have to do is we just need to figure out which ones, where the ones are, and we need to multiply them towards their specific power to the n. So just like we do over here, just figure out where they're at and just multiply it to their specific power n and then just sum it. So let's do this over here. We're going to try to convert into binary. So remember, the first place is the origin place, which is 2 to the 0. You subtract going this way. Subtract 1. And going this way, add 1. So what's happening here? 2 to 2, 3, 4, and 5. 2 to the 5. And here's 2 to the negative 1, 2 to the negative 2. So what's going to happen is 2 to the 5 plus 2 to the 2 plus 2 to the 0 plus 2 to the negative 2. What are we looking at? 32 plus 4 plus 1 plus 0.25. Remember, this is 32. That's 4. That's 1. That is 1 over 4. So that leaves us with 37.25. So 100,101.01 in base 2 equals 37.25 in base 10. Easy. This one's straight up easy. We'll do the same thing. No decimal at this point, so we just have 2 to 0. We skip the 2 to the 1. 2 to 2, 3, 4, and 5. Straight up addition. 2 to 5, 2 to 4, 2 to 3, 2 to 2, and 2 to 0. 32 plus 16 plus 8 plus 4 plus 1. What is this? 48 plus 13. And that's going to be 61. So 111101 in base 2 equals 61 in base 10. Now convert, same thing, 0, 1, 0, 1, 0, 1, 2, 3, and 4. 2 to 0, 2 to the 2, 2 to the negative 2, negative 3, negative 4, and negative 5. So what we're looking at is add all of these powers of 2. So this is going to be like a bigger fraction since we're heavily indexing into the fraction parts. So what we're looking at is 4 plus 1 plus 1 over 4 plus 1 over 8 1 over 16 plus 1 over 32 equals 5 plus 32, so that's 8 32 plus 4 over 32 plus 2 over 16, 32. So the answer is, we got 12, 14, and 15 over 32. So what's 15 divided 32? So 0.101.01111 in base 2 equals 5.4687 in base 10. Well, thank you guys for watching. If you guys want to hear from me again, please leave a like, comment, and subscribe for some more computer organization educational content. There's a lot more to come from. Thank you guys.